Okay, well, thank you very much for having me here. It's a pleasure to be here in Tokyo. My name is Melnykowycz. I'm from a startup in Switzerland, IDUN Technology, where we do a brain-computer interface. I also work doing nonprofit work at the Foresight Institute in San Francisco, where we look at other technologies, what's happening in the world. Also in the background from Neurotech, so it's an organization which is also talking about technology for the world, really focusing on education and sharing essentially what we do with neurotechnology. And for example, with the Foresight Institute, there's a mandate about advancing technology for the long-term benefit of society. And the topics there include a lot of things such as intelligent cooperation, space, molecular machines, but also neurotechnology. And then at IDUN Technologies, we focus on building a brain-computer interface throughput system. So we make it extremely easy to connect the brain to the internet by using conductive earpiece electrodes. So we read the brainwaves inside your ear canal, and then bring it out to the top level. So these all come together with two interesting things. Neurotechnology and neuroscience in general is one of those complex things that we're trying to understand as humans, as researchers, or when we're building products, it's one of the most complicated products to build and bring to market. We're continually working to understand structure and function of the brain, understand how can we bring different treatments or interventions into the world, whether medical, but also from consumer and wellness. And a lot of this is focused around the neuromarkers that we can capture. So as Mal was talking about, capturing neuromarkers for medication, for example, and then bringing that into a different product sphere. And long term, we're really looking to solve things like dementia, neurodegenerative disease, and bring together a lot of these different concepts and problems. So for neurotechnology, neuroscience, what we're seeing is how can we create tools or technologies that can really track the entire landscape of neurotechnology so that we can get over some of these hurdles or some of these challenges we have, like creating scalable biomarkers, so creating these neuromarkers in the brain that are transferable over products and systems. And then also into concepts like enhancing human cognition and performance. So nowadays we have, many of us have eyeglasses, and no one thinks that it's strange to use eyeglasses to enhance your vision. But the concept of using a brain implant to enhance your cognition is probably something that most people are still wondering if it's a good idea or not. But in 20 years, maybe we'll all have brain implants, and much in the same way that people are doing cosmetic surgery, and it's not a big deal. So we wanted to use a tech tree concept to map out neurotechnology at the Foresight Institute. So many of these familiar with things like mind maps or ways to capture different systems. So we essentially wanted to apply the concept of system thinking and knowledge graphs. So bring together everything into a map of neurotechnology, the landscape of the industry and the research initiatives. And this is being done as a project at the Foresight Institute. And as part of this, we wanted to also think about how this can help to empower decentralized science and also act as essentially a domain graph or a domain foundation for decentralized science initiatives. But first, I wanted to take a step back and think about the scientific process in general. So whenever we go through scientific analyses, whether in industry or in academia, we have to start out with having some sort of question, we go through experimentation, then we go towards creating results and data, and then eventually publishing or communicating our results to the world. And we do this generally, if you're a scientist and you're interested in astrology or neurology, you research that area. But we don't always have a very centralized way to dictate what should be research. We do what we love, which is why probably everybody is in this room. What we would like to know is that industry perspective or entire landscape, are we asking the right questions at the right point in time to the benefit of society? And are we then actually allocating the resources that are needed to get to those answers? And we want to investigate this for neurotechnology. So you have the scientific process. Then we have the way that we're actually going from a basic research question to something society. So we generally are doing science in laboratories. This can be a very centralized organization at universities and also research institutions. From there, we're generally trying to create a technology, because after we make a discovery, we make a technology. So technology is something which is reproducible and can ideally scale. And if it scales well enough, then we want to create a spin-off company from a university lab, and then build it into a scalable, sustainable product company. Because this is ultimately the way that we solve problems in society. It's like commercialization of different mechanisms. And that allows us to really scale because we have a business value behind the thing that we're solving. So it comes back to the same question. Are we actually building the right companies to impact society? Or are we building companies that aren't actually going to be sustainable in the real world? And when we go through these innovation steps from laboratory to final product, we also have this question of how do we actually allocate funding to different projects or companies or research laboratories at different points in time? What are the metrics that we should be using to actually evaluate a research organization or a research question? And depending on where we are in that funding phase, we get oftentimes different types of funding mechanisms. So national science foundations having centralized funding for research institutions that is quite common, whether in the United States, Europe, or Japan. Then sometimes a researcher has an idea for a company that they then get a seed grant or seed business angel funding to start a company before you can actually build it into an organization, at which point then you start to look for venture money. But we don't have a tool which allows us to really understand what type of funding should be going into a company or an idea at what point in time. And also for a lot of organizations, we want to actually predict where funding is going to be needed to really solve a lot of problems that we have in the world. Then when I think about decentralized science and a lot of topics that are being built nowadays, the DAO organization provide a lot of opportunities to solve different parts of this value chain, the science development process. The big one, I think most accessible, is the funding question. So having a DAO for hair, for example, or for longevity, like DAO, makes a lot of sense because you can automatically capture a lot of funding and then direct it to different directions. The other point that's coming up is the allocation of actual resources. So DAOs like LabDAO are trying to make it DAO actually building resources and allowing them to be decentralized. Because right now, if I have an idea for an experiment I want to do, but I don't have a background in biotechnology, it's going to be nearly impossible for me to do anything. If I am a typical lab that already have decentralized funding for my laboratory, then I have the resources to solve the question. And one idea is, how can we actually change or decentralize that whole mechanism? And that's where I think the DAOs and DeSci are going to get a lot of value. And with neurotechnology in general, it's a super complex field. We've been working with the idea of understanding the brain for hundreds of years. First, thinking that emotions are things that are being manifested by God, and we use religion sometimes to help contextualize what's happening in our minds. But now we also have super highly advanced things like MRIs magnetic spectroscopy, where you can really image what's happening at a structural and functional level inside the brain. But we wanted to then also connect that up with other solutions. And neurotechnology in general is also super complex because we have non-invasive versus invasive technologies. We have the ability to train and learn neuromarkers and different applications. And then we have big centralized areas for actually collecting data and bringing it into a place where it can be used. And that's why we started to come down to the idea of building a large knowledge graph, so the neurotechnology tree, which is capturing everything that's happening in the neurotech field. This is being built by domain experts. So the Neurotech technology tree team from the Foresight Institute was based around a colleague of mine, Melnykowycz, who's at the DeSci Institute for Cognitive Neuroscience in Leipzig, Germany. Russell Hansen, who's a really expert in AI in New York, and then Sebastian Wolf, who's really an expert in also creating brain-computer interfaces and basic unit. So we were working together to create this neurotechnology tree landscape, and that included also the background of the tool. So the tool was coded using resources from the Foresight Institute, and then we were putting in the information to conceptualize the neurotech field. And we wanted to structure the flow of the tree to go from technology area, so the tools that we have as neurotechnologists, to applications, so the things we're actually building, like interventions for dementia, and then the challenges and bottlenecks we have. So with dementia, with Alzheimer's disease, this idea that we're not capturing enough data to actually conceptualize the disease, and we're not actually able to predict early onset of dementia yet. Because of that, we don't get interventions early enough into people, or we can't develop clinical trials in a good enough way to actually build solutions. So the idea of the tree is that we can conceptualize this technology and start building new technology nodes as they become available. And we're looking for ways that we can actually connect the different nodes together so that we can predict what type of solutions are going to be required to get over these barriers that we have for the future. So if we want to solve dementia, the idea of building scalable neuromarkers that are staying with a person over time is one solution. And the tree is really there to allow a person from any field to look at neurotechnology in general and see how their research, how their funding, how their entrepreneurial idea could fit into that entire landscape. And then the Foresight Institute is also doing this for the machines and space and these other focus areas. So our first expanding version of the tree starts with technologies, applications, challenges, and goals. So we're laying out technology on the left-hand side and then building nodes through applications and challenges where we can see the relationship from one entity to another entity. For example, the brain-computer interface allows us to build neuromarkers, which allows us to build applications for depression, for example. And one of the big challenges we had is that as you start to build this tree, it becomes very large. As humans, we always have this problem where we can take in a certain amount of information. We can understand a certain amount of information in our short-term memory, and this is the whole reason why we write stuff down or record ideas, because we can't always access the information that we have or that we created. And this is also one of the challenges we have for the technology tree, because it's also a ton of information. And if you just try to look at it at one point, it's very difficult to conceptualize the entire landscape. And this is the purpose for having a mind map structure where nodes can logically be connected from one to the other. So this was a good foundation. The coding of the tree is done also in web technologies using an XML structure. so that we can have different descriptive nodes, tags, and also a relationship, so the parent-child relationship, so that we can create this logical organization in 2 dimensions. And we've gotten to the point where we're able to build out a very large graph. So essentially, we've created a knowledge graph. Knowledge graph is just something where you've taken one entity or one focus area and you've created a lot of structural knowledge around that. Which is not unlike what essentially we do with the brain. Our brain has a lot of knowledge, it has a structure and function. So we really like to build this knowledge graph, and then the question is, okay, if we build this, we have the knowledge for, let's say, one point in time, but we also don't really fully understand how this knowledge graph is related to new ideas that are coming up in neurotechnology. So even though it's now very easy to go through the graph and to click on nodes and to get more information about each part of the neurotechnology landscape, we're looking for ways to expand beyond. So one way to do that is to start with the tech tree and essentially create it as a foundation, as an input for another system. Because as domain experts in neurotechnology, we've been able to create that structure where you could say that our concept of the neurotech landscape is vetted, or we've been able to establish a baseline for the neurotech landscape at this point in time. And again, we have this certain structure. We have a node, it's got some certain information, and that means it's perfect to now be a graph or a knowledge graph that can be queried. So each node can now be a search term for another application. And that's what we started to create in the next architecture for the technology tree. So what we started to build is the concept where the technology tree, this knowledge graph, can be used as query input for other knowledge-based APIs. So if you're familiar with APIs for scientific research from PubMed and other organizations, or the US Patent Office, you know that they have APIs which are easily accessible so that we can automatically grab queries from one knowledge graph and then pull in the API information and list and export all the information from the API for those specific query nodes. So this is one example of what this could look like. You can have a node as a query for the US Patent Office. That node query can also go into the list of different science graph APIs. So, for example, Biomed, Harlequin, Elsevier. A lot of these places have relatively open APIs, which allow us to now feed all that information into the technology tree. And if you want to query for a publication based on one or two nodes, you can very easily look at the title and the abstract, and that can all now be done automatically through the API. And the same thing is possible for patents. So if we have EEG and depression, we can pull those node inputs from the technology tree, and then see what happens when we pull that information back from the patent office API. Specifically, we're be interested in things like how many patents have been made around EEG and depression, or how many patents have been made around dementia and EEG. Because that would be the relationship between the technology from Neurotech and the actual solution that it's being focused on. And if you were to do this with different online tools like conventions, you can easily query the number of citations as well. So for MEG and biomarkers in depression, for example, we can see the number of people that are creating knowledge in that area with more specific time period. And then if we were to do this for publications and also scientific journals, we oftentimes see in different research areas that when a new idea is coming up and there's a lot of interest behind it, that the number of citations will go up over a certain amount of time. And theoretically, if the topic has been well researched, you'll probably start to see some sort of plateau of the number of citations versus the overall citations that are being created every day and every year. in scientific databases. So we can start to create metrics for essentially the research momentum of an idea or a topic at different points in time. And this is cool because it essentially tells us how much effort is being put into trying to research a very specific topic, like a MRI plus depression or MRI plus dementia. And if we do that, we can then also start to experiment with different platforms that are doing this on back. So we have this concept for the structure and function of the technology tree. Then we started querying different APIs with the tech tree node inputs to now see how we can be grouping or clustering the number of publications that are coming out of each individual node. And then again, is giving us an idea for the relationship between different neurotechnology endpoints like brain-computer interface and G, or also the type of mathematical model that's being used to actually develop neuromarkers. For example, convolutional neural networks, which have become quite popular to create neuromarkers for EEG signals. And also, when we look at then querying multiple inputs together, looking at EEG and depression querying within the same title or full text search, and it really allows us to vocalize how many of these nodes are being worked on together. So this was a bit of the background of the concept we put together for the creating the next structure of the decentralized science. So we start with the concept that from the neurotechnology tree or from other trees, we are looking for essentially gaps in knowledge or gaps in research. Because this is really the central question that we have for a lot of points of scientific research. We currently have centralized funding organizations like the National Science Foundation. If you want to get money to research something, you create a proposal and you submit that proposal to the centralized organization. But they're also going to have essentially control over the money which is going into creating answers through science. So one question is, how do we decentralize that? Well, one point is to have organizations like Bitcoin, DAO, and other DAOs, which can provide the mechanism for collecting funding to go towards specific research. For the technology tree, the idea is that we can understand where the gaps are in the current landscape of the science, in this case, neurotechnology and neuroscience. And then from that, it's possible to start creating roadmaps for funding, like where we actually put funding in order to solve some of the big problems we have in neural disease and prevention. They created a first experiment with using Bitcoin with the Neurotechnology trees and the other tech trees from the Foresight Institute, where Bitcoin bounties were created for different points of the tech tree. And then those could be put out as challenges, and then people could submit solutions to those challenges. And what's really interesting now is that the idea of using the database DAOs like the DD DAO, for example, is really great because it means that information that's being created can also come directly into this DeSci structure as well. And LabDAO is really interesting because this is a place of being able to decentralize the resources for actually doing new scientific experiments. So if we're creating a challenge in Bitcoin and we see that we want to do a certain type of experiment with neurotechnology, then organizations like LabDAO can help to provide those resources for research. And then ultimately, we want to build that into creating a solution pipeline where we're going from concept of what's needed in neurotechnology to solve these problems to a full pipeline of bringing in the resources and actually making it relevant. So that's essentially what we've been creating as part of the Foresight Institute and the tech tree landscape. It's a tool that we created the foundation for, and now I want to build upon it and bring it also to different stakeholders in the DeSci community and see how it can be created as a larger, more sustainable tool or helping to push funding into the right place where we need funding and resources to create solutions in society. So that's a basic part of what we're working on. I'd be really interested. That's going to be a great place as well to get feedback on what you think of that concept. How you imagine it being useful, or there's certain, let's say, deficiencies that you automatically see in that type of model. And I'm really interested to hear what your feedback is. Thank you.